Good afternoon, everyone. Yeah, there are still some more people to join. Okay, I think we'll start off. Okay, so there is one thing we have to do a readjustment here because of the mid-sem break next week. Okay, so since this is a core course, we cannot have any activity. And so, yeah, so this assignment will have to be postponed. Okay, so 27 to 4 is the break announced by the dean. You might be aware of it. So yeah, so these assignments will be postponed by a week. Okay, so this will be for April 5th. This will be for April 12th. This will be for April 19th. This will be for April 26th. 26th. So end sem we will have to keep the next week. That is 3rd May. So yeah. Because yeah, 7th May is a lecture ending, so we cannot overlap with any other end semester exams. Okay, so we will have to finish it off the week before. We wanted to finish 2 weeks before, so that 1 week you will have free, or we can also have makeup labs whoever have missed due to medical reasons. But yeah, so that is not something we can afford because 1 week is cut off. Okay, yeah, so this is something that you need to keep in mind. Yeah. Yeah, so we'll consolidate the Viva marks and upload in a day or so. And sorry, something bad. Okay. Yeah. So just to see. So yeah, this is when the semester ends. Okay. Yeah. So 7th. So this will be lab exam. Yeah, I'm very sorry. Okay. So I may have to restart this. Yeah, sorry, something crazy happening here. I will get back in a second. Okay, so that's a good point. Okay, so yeah, so actually there will not be any end sem viva. Okay, so yeah, so what I've realized is whatever concepts that can be asked or the fundamental concepts of object oriented is already done. So there will not be a viva. I'll send an email and see response from others. Okay, so what we will probably have is a quiz kind of thing. Okay, so that will be done online. That's like a 15 minutes short questionnaire that you need to answer. Okay, because now onwards it's essentially about how you use the standard template library and also basically programming it. You don't. Oh, okay, I don't know what is happening. Okay, so you don't really be teaching much. So next lecture will be the last lecture. Okay, so there will not be any further lectures. Okay, yeah, just to set things right. So we'll be introducing standard template library today. From now onwards, you are free to use standard template library, but only for the fundamental ones, not advanced ones. For example, there are also template libraries for graphs and so on. You are not allowed to use that. You need to build your own. So the next 4 assignments are going to be implementing algorithms from, it most likely it will be taught in course. I mean, it may not be exactly synchronized. So next will be, this one is a graph algorithm, basically BFS and then a shortest path version of out of it. Next will be, yeah. Okay, so yeah, next is either minimum spanning tree or shortest path. It depends on what is done in the class, of course. And then after that, after that it will be so dynamic programming, and then shortest path MST. I think there will be 3 assignments, 1 dynamic programming. Okay, so that is how it's going to be. So it will be implementation heavy. It's basically you will be exposing yourself more into STL and then also algorithmic techniques. Okay, so far except divide and conquer, we haven't seen any algorithmic techniques being implemented. Okay, yeah. Okay, so today we are going to quickly see the standard template library. This is one of the real big features of C++. Okay, so we will see only the fundamental classes that are available to us. So the C++ library is so huge. I mean, it's user contributed. So there's lots of libraries for almost everything, every object that you want to talk about. That is an implementation of template library. Okay, so yeah, so once you get a handle of how to use and so on, the programming becomes much simpler. Okay, compared to C. I mean, of course, C also has a lot of libraries, but yeah, the template library is very generic. Okay. So the main feature of the standard template libraries are containers. Okay, so these are container classes, which are basically generic objects, basically templates. Okay, so there are 3 main types of containers. One is sequence container, basically sequential data; associative container, basically ordered data; and then container adapter. Okay, so sequence containers will consist of vector, list, double-ended queue, array, and single linked list. So this is single linked list, and then so list is a double linked list. Associative containers, basically implementing sets. A variant of it is multi-set. You might want duplicates. Then map and multi-map. Then there are adapters, which are basically those that use containers. Okay, so what we can call as restricted forms of containers: queue, priority queue, stack, and so for example, queue and stack are restrictions of DQ. Priority queue is a restriction of on vector. Okay. Yeah, so these features are essentially they will implement most of the data structures that you would have seen or implemented in the PDS course or an equivalent course elsewhere. So they will be available as built-in objects. Okay, so that is built-in classes. So sequential container, this is a description of sequential containers: vector, double-ended queue, double linked list, singly linked list, array. Array is bit more recent. It's available only in, I think, C++ standard 11 or later, version 11 or later. Okay, and then of course the string class. So some of them you have already used. Okay. So this is one thumb rule I followed from Lippmann's book. Okay, so so there is no hard and fast rule. So what kind of container use? So this is like one simple possible rule that you can think of. Okay, so when to use vector, when to use list or forward list, and so on. Okay, depending on how do you want data to be how the data needs to be accessed and so on. Okay. So we'll see a little bit quick insights into some of the container classes. Okay, so vectors are essentially implementations of dynamic arrays. So there will be contiguous storage. storage handled internally without involving the user. So this is the advantage of object-oriented programming. So this data management is completely internal. Okay, so user doesn't have to. So unlike C, where, for example, array you will have to manage on your own. Okay, so this is so what we will have is for our program for the programmers we'll have interface. Okay, so implementation is hidden. So implementation is done only once. I mean that's of course the purpose of libraries. But here it's like, yeah, what you are given is like access methods. You don't even have to handle data. Okay, so data storage is done within the classes. I mean objects. Yeah. So yeah, so these are the functionalities. So this is one example use of vector. So the library is you just use hash include vector. Okay. Yeah. So this. So I'll come to this iterators a bit later. Okay. Yeah. So this. Yeah. What it does is it adds element to the vector at the end. Okay. So that is value I. So I goes from 1 to 5 will be added at the end. Okay. So when it prints, it will print 1, 2, 3, 4, 5. Okay. Yeah. So yeah, so another such object is a list. So before going to list, I'll just talk about one more object or class available in the container, which are iterators. Okay, so these are again a generic class. Okay, they are very useful. So what they do is like, see, most of the template library classes are to store data, right? Okay, so many a times is how the data is stored. I mean, how do you access it matters. So for example, linked list, when you say ith element or the next element, right? So it's so how do you give access? So iterators kind of unify those access methods. Okay, so iterators is a class. So iterators basically types or objects which have to be implemented by each of the container classes. Okay, so they should be available as member functions. Okay, so member functions begin and end. For each of the container class there is a begin and end. So but these are objects, these are pointer objects. Okay, so that is they point to the first element. So begin would return pointer to the first element and end pointer to the last element. They are not exactly pointers. I mean, you cannot trade them for pointers, but they behave pretty much like pointers. Okay, they can be implemented with plus plus, dereference with star, and you can also compare them with each other. Okay, so there you can just imagine in the case of array iterators are indices. So these are generalizations. Okay, yeah. So it also depends on the container. Some of the containers support only these operations, but some of them also you can move forward, backward, compared with less than symbol and so on. Okay, so this is an example of iterator. I mean, we have already used in the previous slide. Okay, so we are declaring vector. So this is a library iterator. Okay, so vector int array is initialized with this. So now we declare an iterator variable, but the iterator type should be of vector. So vector int, within that scope, iterator. So each of the container will have its own iterator. Okay, so pt is an iterator with of vector type. Okay, now so array dot begin represents the first value or pointer to the first value, and array dot end to the last value. Okay, so one way to use iterators is you say for pointer is equal to array dot begin, pointer less than or less than or equal to array dot end, pointer plus plus. Okay, so see out. So if you dereference, it will give the value. So at the first iteration, star pt will be 9, then 10, then 3, then 6, then 10, then 20, etc. Okay, so these are one useful objects. I mean, this is again part of so hiding the implementation from the user. Okay, so it really does not matter. So once the container supports iterators, you just pretend like these are all like array objects. okay, but only thing is you have to use this begin and end function, and these should be treated like pointers, okay. Yeah, so now I'll quickly give some more examples of these classes. So double-ended queue. So I mean, so this functions like a queue. Okay, so it supports operations. Yeah, so internally it is basically a vector of vectors. So constant time for push, pop, or front, back. So there is also this array operator, that is bracket operator, that is supported here. Okay, so you can access ith element if you want. Okay, so the way do is you say declare dq. So of course it is template, so you can have either your own class or sorry, any of the built-in data types. So this will push at the back, this will push at the front, this will push, this will, yeah, push at the back, front. So at the back it is 10, front it is 20, back now it becomes 30, this becomes 15, okay. So yeah, so now this basically is an implementation, so our own function, which basically shows the content of the queue, okay. So to show dq, so it uses iterator, so from beginning to till you reach end, you show the content, okay. Yeah, so I request you to type this in your terminal, and I mean in an editor, and run the program and see for yourself, okay. And yeah, so this is something, it's slightly relatively new. So since vectors were there, people were already using array. At least the justification they give is like this implements slightly faster than array, vectors, in particular if you want to implement arrays. But only thing is these are fixed size. So when you instantiate, you have to say what is the size of the array, okay. So at is a function supported, which gives element at that position, okay. Okay. Yeah, so one thing is here you don't, I mean this operator is overloaded to the array class, so it basically behaves like array, okay. Yeah, so forward list is a single linked list. Only thing is it cannot be iterated backward. So, and yeah, so it depends on the applications. If you are familiar with hashing, this is certainly useful for chaining in hashing, and possibly for adjacency lists, implementing adjacency lists. Maybe you like forward list rather than list, which is double linked list. Okay, it just particularly when you have a large graph or whatever, so this might be a bit useful because it takes less memory. You don't have backward pointers. Okay, that is a one advantage.
How is DQ a vector of vectors?
No, that is their implementation. So yeah. So internally, that is how it is implemented. I don't have much details of the implementation as such.
Okay, sir.
Yeah. So internally, it is implemented as vector of vectors. So yeah, I don't really know how it could. Okay, no idea. Yeah, what you're saying is right. I mean, vector of elements should be enough, but yeah, not clear. Okay. Yeah, so then these are associative containers. Okay, so set is an associative container. So basically implements our set. Okay, so in set the data is unordered, so that means you store it in sorted order. Okay, one thing is the values will be unique. You cannot change the elements. Okay. Uh, yeah. So again, this is implementation. So internally, it is implemented as a binary search tree. You might have heard of in your programming and data structure, or you might have used in or implemented in programming and data structures. Okay. So for example, if you look at this sequence of insert operation, okay, so this again, I will not discuss much in this lecture. I'll talk about it later. So this basically says the data contained is integer type. Now this is a functor, okay. So this is a functor. This is basically objects which are functions, okay. The operation, the purpose here is basically they provide functionalities, okay. So here this greater is again, it's used in the implemented in the STL library. It basically says the greater or equal to comparison or less than or equal to comparison. So now this, what it does is, so it enforces the set to store elements in sorted order, okay. So that is all. So yeah. Insert 40, insert 30, insert 60, 20. So, but they will be sorted in descending order. 60 will come first, then 40, then 30, then 20. Insert 50. Now you're doing insert 50 again, but it won't create a copy. Okay. So these are having unique values. So this will retain only one copy. Basically how sets should be, and then 10. Okay. So when you output, they will be in the descending order because of this greater. Okay. By default, it's ascending order. So there are also other functions: erase, clear, find, upper bound, and so on. I will not really go into the details of this. Then in case if you want a set where duplicate values need to be taken care of or they should be retained, okay. So in that such cases you can use multi-set in place of set. The syntax and functionalities are essentially the same. Only thing is, so in this example 50 will appear twice, okay. So yeah. So there are also functions erase, clear, upper bound, and so on. Okay, so I'll skip all that. Yeah. So yeah.
So in the previous slide, what does the erase 50 do? Does it erase both the copies or does it erase the first copy, or how does it work?
That is a very good question. So yeah, as far as I understand, it should erase both the copies. Yeah. Yeah. Okay, I haven't tried this program yet. Maybe we'll try it towards the end. Okay, so we'll see. That will answer the question. Yeah, we'll copy paste and run this. Yeah. Okay, so this is again. So in certain situations, you might want to represent functions, okay, or in abstractly put maps, okay. So basically, key and value pairs, okay. So here key should be unique, okay. Yeah, so yeah, we'll not really go into this. I don't know if some of you heard of. So these are implemented as what are known as red black trees. They're kind of used in databases as well. Okay, so yeah, so here what you need is so yeah, it can be heterogeneous. So that is one. So basically want to implement ordered pairs. So the first element could be some type and the second element could be some type. So when you instantiate, you need to specify both. Okay, so this case it is both int and. Only thing is you need to use this constructor for pair. Okay, so pair is again a class. It basically represents ordered pairs. Okay, so you insert them in pairs. Okay, so so each element is a pair there. Okay, so pair will have first coordinate is 1, 40, second coordinate. So in the second element, first coordinate 2, 30, first coordinate 3, 60, 4, 20, and so on. Okay, so yeah, so here only thing is, so this key values should be unique. Okay, so yeah, so that is a speciality of map. Okay, so basically it works like a function. Okay, so function, there is a unique value associated with each element in the domain, right? That's exactly what it is. Okay, so so you can just imagine this is representing a function where f of 1 is 40, f of 2 is 30, f of 3 is 60, f of 4 is 20, and so on. Okay, so but here you have the freedom to change the domain, and so I could have this as float. I could have my own class objects, a class type. So here again, it's the same thing. Okay.
I could have double char whatever. So it's yeah. So then there is a version of map where you can duplicate keys. Okay. So but the only condition is key value pair should be unique. Okay. So key value pair should be unique. Otherwise you can repeat the keys here. Okay. So it functions pretty much similar to a map. So you can use find, count the number of pairs which match certain criteria, or yeah, erase and the clear whole map. Okay. Yeah. Now these are like specializations or restrictions of the existing ones. Okay. So Q, most of you would have done in a data structures course, must have implemented. So it's a first in first out object. Okay. So it's a structure where element which arrived first will be removed first. Okay. Yeah, so these objects like you must have already used or you will be using in today's assignment. So they're kind of fundamental. Okay. So here insertion happens at the end, deletion from the front. Okay. Of course, you can implement using DQ, but they already have the implementation. Okay. So it supports push and then front and then back. Okay. You can also have pop. Okay. So push pop is usually the terminology used for stack, but the same function name is used for Q as well. Okay. Yeah. So then yeah. So this is something you might have seen already. I'm not sure. So have you heard of priority queues? Have you used it? Have you used this term, priority queue? Okay, okay. So yeah, so those who haven't seen, I mean, if you are doing the CS2810 course, so they will soon be needed for implementation of certain algorithms. Okay. Yeah. So for example, the assignment today, right? So the second part could be implemented using priority queue. Okay, it's easier to implement using priority queue. Okay, so here what you have is, so it's essentially a queue structure, but the first in first out criteria is changed with respect to the priority. Okay, so you have priority value, or in other words key value associated with each element in the queue. Okay, so now now you can tell so whether the priority is least, that is its minimum or maximum. Okay, so now when you say, when you want to remove an element, so it will be the one with the highest priority or the least priority. I mean, when I say least, I mean the least value. Okay, or in principle the highest priority. So if you are implementing min priority queue, then the element with the least value will be taken out. Okay, and if it is max priority queue, element with the max will be taken out. Okay. Yeah, so this is one thing is you might imagine, okay, so then this can be implemented as a queue or just as a vector. Well, it is implemented as a vector, but you might have already seen the heap structure, right? So it is kept as a vector, but there is something called a heap. Okay, so I hope all of you have heard of it. So heap, the advantage of heap is removing an element or adding an element takes order of log n time. Okay, so even there are implementations which will even reduce the time amortized, but otherwise it will take order of log n time, worst case time. Okay, so in many applications, implementation of priority queue where adding and removing an element taking order of log n time is kind of crucial. Okay, so they drastically improve the running time. Otherwise, if you just naively implement it as a vector, it's going to take a linear time because you will have to adjust the elements and so on. Okay, so because remember that vector is a pretty much like an array, right? But with the additional supports. Okay, So, I mean, additional functional supports. In fact, a dynamic array. Okay. So, yeah, so this is an additional useful structure that you need to know about. Okay. Yeah, so then this is another very useful structure, that is last in first out structure, or first in last out structure, which we call as stack. This again you might have implemented in your PDS course. Okay, so this again functionality is very similar to queue, but except that insert at and remove from the same end. Okay, so of course you can implement using DQ, but they are explicitly available to us. Okay. Yeah. So yeah, so where was that question? So let's take that out and maybe run it out. Okay, so if there are any questions, please shoot in. Yeah, so you can implement, I mean, you have min heap as well as max heap. Okay, so yeah. But if you know the implementation of one, that's fine. I mean, you can also implement the other. Okay, so I'm going to check this. Okay, so yeah, so that is it for today. So those who have questions, please stay back. So I'll also run that code that I had promised. Okay, so I will stop the recording for now.